So as you know, the final exam is cumulative, so it covers material from tests 1, 2, and 3. It's equally weighted and the order is shuffled. So that means that one of the most challenging things about this test is trying to figure out which methods are appropriate. So that's what we're going to focus on in this week's videos. We're going to be focusing on choosing appropriate graphs, statistics, tests, sampling methods for a given scenario. Before you start the review, I would recommend printing out this topic organizer. This is going to organize everything that we've done this semester in terms of the response variable and the explanatory variable. Let's start by filling in just the top row of this table. So this is where you don't have an explanatory variable at all. You just have one variable, could be categorical, could be quantitative. So the first thing I want to do is to practice sorting out the different statistics and the symbols that we use for those. So these sets of words, those are going to need to go in the top row where it says numerical summaries. And then you've got 6 different symbols here. And I want you to sort those out based on whether they're statistics or parameters and whether they're for categorical data or quantitative data. And just to kind of help you think about it, I've got some sample statistical questions that you could use. So go ahead and pause the video here, fill in the top row of that table, and go ahead and commit to your answers, write it in pencil. I promise you'll remember it better if you struggle with it yourself instead of just letting me fill it in for you. All right, check and see how you did. So on the categorical side, that's going to be summarized with proportions and percents. So a question like what percentage of MSIT students are taking the final, that would be a question about a categorical variable. So notice we use p hat to describe the sample proportion. It's a statistic because it describes the sample, and we use just regular p to describe the population proportion. If it describes the population, then it's a parameter. If you have quantitative data, that's where you're going to describe it with measures of center and measures of spread. So it could be mean, median, standard deviation, and IQR. In these sample questions, what is the average grade on the final exam? That's a question about center. How variable are the grades on the final exam? That's a question about spread. And then you see the symbols that I use. Y bar represents the sample mean, and S represents the sample standard deviation. Those are statistics. Mu represents the population mean, and lowercase sigma represents the population standard deviation. Those are parameters. So which values do you use? Statistics or parameters? Which measures of center and spread do you use? I've got some questions here. Go ahead and pause the video again and see if you can figure out how to complete these statements. All right, if it goes in the null or the alternative hypothesis, that's going to be a parameter because you don't need hypotheses to tell you what your statistics are. You can just calculate those from the sample. But we do need hypotheses to think about what happens in the population. If it comes from the jump output, that's a statistic, right? That's a number that's calculated from the sample. When the data are skewed, you want to use measures that are resistant to skew and outliers. So in that case, you're going to want to use the median as a measure of center and the IQR as a measure of spread. And sort of related to that, if you look at the graph here where we have data that is skewed right, that's going to pull up the mean, right? The mean is more sensitive to outliers and skew, and so the mean is going to get pulled up, whereas the median is going to be more resistant. So in this graph, the mean is going to be higher than the median. Let's go ahead and fill out one more thing on our topic organizer here. So we're going to fill in the section about graphs. So notice that some of these graphs are just going to be for displaying one variable. So this says no explanatory variable. This would be where you have only one categorical variable or only one quantitative variable. Whereas these 3 boxes are for looking at the relationship between 2 variables. So for each one, think about what the response variable is and how you classify it. Think about what the explanatory variable is and how you classify it, and then put the graphs there. So to make it a little bit easier, this slide has some examples of the different graphs types. Take a look at these and see if you can fill in where they go on your topic organizer. So let's start with the graphs for univariate data. So univariate means that it just shows one variable at a time. So for categorical data, you have 2 options. You could use a bar graph or you could use a pie chart. I tend to recommend bar graphs because they're a little bit more flexible. Pie charts, you can only use those if all of your values add up to 100%, if you're representing all categories and each case is only being counted once. Also, pie charts can just be a little bit hard to read because it's a little bit hard to see how big the angles are. For univariate quantitative data, you have two options. You could use a histogram or you could use a box plot. So even when we're looking at relationships, we're going to use the same basic tools that we learned for one categorical variable or one quantitative variable. So if you're looking at the relationship between a categorical response variable and a categorical explanatory variable, you're still going to be looking at proportions, but you're going to have more than one because you have more than one group. So basically the idea for categorical data is that you're going to be comparing the proportions for the different groups. And the easiest way to do that in a graph is by using a mosaic plot. So mosaic plots allow you to look at the distribution within each group. And if the distribution is different in the two groups, you say that there is an association between your explanatory variable and your response variable. So what if you have a quantitative response variable, but your explanatory variable is still categorical? So essentially you want to compare groups for some kind of quantitative response. So you're going to be comparing the means or the medians, depending on what type of data that you have. So probably the easiest way to do this in a graph would be a parallel box plot. So parallel box plots allow you to look at the quantitative variable and how it's distributed for all your different groups. And the last one we'll look at here is the relationship between a quantitative response variable and a quantitative explanatory variable. So this is sort of different summaries that we would use. For this, we would look at the slope or the correlation. We did our hypothesis test in terms of the slope, so we saw both a statistic and a parameter there. For the statistic, we did that as B1, that's the sample slope, and the parameter is beta 1, that's the population slope. We also saw some other statistics like the correlation is R, R squared tells us how much variability is explained. We didn't really do hypothesis tests for these, so we didn't write them in terms of parameters. And then the graph that we're going to use to examine a relationship between two categorical variables is a scatter plot.